All right, so if a projectile is launched vertically upward from the ground with an initial velocity of 60 feet per second, neglecting air resistance, its height s in feet above the ground, t seconds after projection is given by, and this is the formula, what equation can be used to determine the time at which the height of the projectile reaches 40 feet? So the 40 feet would be s, so s is equal to 40. So basically, in this equation, we're just replacing s with 40, and that's all this one wants us to do. It doesn't need us to solve anything. So it'll be 40 is equal to negative 16 t squared plus 60 t. And so if instead they had given us time, we would have plugged it in for t and then left s alone. All right, skipping 2, look at 3. Suppose that the quadratic equation s equals 0.0538x squared minus 0.807x plus 8.84 models the sales of new cars where s represents sales in millions and x equals 0 represents the year 2000, x equals 1 represents 2001, and so on. What equation should be used to determine the sales in 2010? So how many years since 2000 is 2010? 10. So this is going to be for x is equal to 10. And so then all we're doing is plugging 10 in for x, and that's it, because they just want the equation in this one. So s equals 0.0538 times 10 squared minus 0.807 times 10 plus 8.84. On the next page, number 5. A rectangle has an area that is numerically twice its perimeter. If the length is twice the width, what are the dimensions? So I would start out by writing down things that we know first of all, and then go from there. So we're going to call our width x. We're told that the length is twice the width, so the length is going to be 2x. Now, what is the formula for perimeter of a rectangle? Or how would I find perimeter of a rectangle?
Length squared plus width squared.
Not squared.
Length plus width squared.
Yeah. So it would be 2L plus 2W. Okay. So then we would plug in x and 2x for width and length. So this would be 2 times 2x plus 2 times x. So we would have 4x plus 2x, which is 6x. So this would be my perimeter here, is the 6x value. Now, how do I find, in general, area of a rectangle? Yep. So area is length times width. So that's going to be 2x times x. So that's going to be 2x squared. Now, if we relate area to perimeter, okay, it would be to multiply 2 times our perimeter value. So related to P, it's going to be A is equal to 2 times the perimeter value, which is 6x. So that would be 12x. I don't know why the lighting of this is so bad for y'all. So then we're going to set, so we've done the area as related to perimeter, and we have the general form for area. Okay, so since both of these are equal to area, so A is equal to 2x squared and A is also equal to 12x, we can set those two things equal to each other. So we're going to have 2x squared is equal to 12x. I'm going to move my 12x over. I'm going to move this up here, though, to do it. So I'm going to have 2x squared minus 12x equals 0. Now I'm going to factor so I can solve it. So I'm going to take out a 2x, which leaves me with x minus 6 is equal to 0. And then we're going to set each piece equal to 0 and solve. So 2x equals 0, x minus 6 equals 0. So x equals 0 or x equals 6. Now, can I have a width of 0 since originally we said width was x? Is that possible? No. So this one is not possible. So our width is going to be equal to 6, and our length is 2 times the width value, so the length is going to be 12. So that was ultimately what we were trying to find, was when it asks for the dimensions, it wants to know what is the width and what is the length. Now, I'm not going to do the next one. I'm going to leave the next one for you to do as one of your homework problems, but I just want to make sure that we're refreshed on it because it's easy to forget formulas. But what is the volume of like rectangular box? Yep. So volume is length times width times height. So I just want to make sure you have that formula for when you go to do that. I'm trying to see if I can focus this in better because I don't know why this is like not. If that made it any better or not. I don't know what's happening. All right, let's go down to this one. Hold on. I need to check and make sure I don't have a typo on this problem because I think I Oh, okay. All right, this problem here actually has a picture in the book. Oh, see a picture on page 131. Look at that. So I'm going to draw the picture here. So I tried to reference, like, if there's a picture or something for you to go back and, like, look at it. But we have Grady, the person, who's flying the kite. And that tells us that his hand is holding the kite at 5 feet. So this is going to be 5 feet. And then we have the kite up here. And then they tell you that that's a right triangle. They tell you that this side is x plus 10 and the bottom is x. And then that this is 50 feet. All right, so they give you the picture for it. So anyways, that's why I wanted to go ahead and give you that before we read the problem. So Grady is flying a kite on 50 feet of string. Its vertical distance from his hand is 10 feet. It's 10 feet more than its horizontal distance from his hand. So the vertical distance is this one, horizontal's here. Assume that the string is being held 5 feet above the ground level. Find its horizontal distance from Grady and its vertical distance from the ground. So basically we're trying to find x and then just say what those two distances are. Look up here so I don't drop it. So what do we know about right triangles? Or what formula can I use to solve right triangles from geometry? Yep, a squared plus b squared equals c squared, Pythagorean theorem. So we're going to have x squared plus, and then in parentheses, x plus 10 squared, because we have that whole piece, is equal to 50 squared. All right, so this parentheses here is a perfect square trinomial. So I'm going to have x squared plus 20x plus 100 equals 50 squared would be 25 and 20, so 2,500. So then I'm going to combine like terms, and I'm going to go ahead and move this 2,500 over here as well so I can set up a quadratic equation. So 2x squared plus 20x minus 2,400 equals 0. Now, I can go ahead and arch method and factor it here, but it would be much, much, much easier if I factor out a 2 from everything because they're all even, so I know I can take out the 2. So I would have, taking the 2 out, I would be left with x squared plus 10x minus 1,200. So because of this 0 on this side, this 2 that's being multiplied is just going to go away. It's going to cancel out by the 0 because 0 divided by 2 is 0. So I'm just going to cross out that. So I'm left with x squared plus 10x minus 1,200. So I need factors of negative 1,200 that add up to give me 10. Any ideas? 40 and 30. And the 30 is going to be negative because this number is positive. So this is going to be x plus 40 times x minus 30 equals 0. So then is that both of them equal to 0? What just happened? So x plus 40 equals 0, x minus 30 equals 0. So x equals negative 40 or x equals 30. So does negative 40 work? Can I have a length of negative 40? Nope. So cancel that one out. So that tells me then that my horizontal distance is 30, and we're in feet. Now the vertical one, this one's a little different because we want to know how far it is from the ground. Okay? So we need to account for this 5 feet here as well when we find the vertical. Okay, so we have the 5 feet from the ground, and then plus 30 plus 10. So 5 plus 30 plus 10. So that's going to be 45 feet for the vertical. All right, any questions on that page before we move on? All right, next page, and we're going all the way to the bottom to number 11. All right, so I've got an astronaut on the moon, throws a baseball upward. The astronaut is 6 feet 6 inches tall, and the initial velocity of the ball is 30 feet per second. The height s of the ball is in feet given by the equation s equals negative 2.7 t squared plus 30t plus 6.5, where t is the number of seconds after the ball was thrown. After how many seconds is the ball 12 feet above the moon's surface round to the nearest hundredth? So I'm going to be plugging in 12 feet for s. So I'm going to have 12 is equal to negative 2.7 t squared plus 30t plus 6.5. So then I'm going to subtract the 12 so I can set up a quadratic equation. So I have negative 2.7 t squared plus 30t minus 5.5. So now I can't factor that because no way I know factors of 2.7 and 5.5 multiplied together that give me 30. So any suggestions on another method I might use from the last section?
Quadratic formula.
Yep, quadratic formula. So negative b, so it's going to be negative 30 plus or minus the square root of b squared, so 30 squared, minus 4 times negative 2.7 times, that's a times c is negative 5.5, all over 2a, so 2 times negative 2.7. And at this point, I would get out your best friend, the calculator, and find the answer, because you're not going to want to do any of that on your own. But I will just tell you, if you don't want to type it in right now, that's fine, that the answers that you're going to get when you solve, because remember, you have to solve both of them. You have to solve for the positive one and for the negative one. So there's going to be 2 answers to this problem. Is that it's going to be 0.19, it's glitching, 0.19 seconds and 10.92 seconds. Okay. So this happens because when it's thrown upward, okay, he's throwing it upward. On its way up, it's going to be 12 feet above the moon's surface, let's say here, but it's going to go past that, and then on its way back down, it's going to hit it again. And so that's why we have two different times that it's hitting. I would say probably use this problem at some point to put in your calculator and make sure that you're typing things in correctly. And if you have a problem, let me know. But we don't need to do that right now. How many seconds will it take for the ball to hit the moon's surface? Round to the nearest hundredth. So that's basically just solving this initial equation for t, but we would put in 0 for s because it would be 0 feet above the surface of the moon at that point. And so this would be 0 is equal to negative 2.7 t squared plus 30t plus 6.5. And so again, you would do the quadratic formula. This one only has one answer. So my guess is that the other one comes out to be negative time, which we obviously can't have. So negative 30 plus or minus the square root of 30 squared minus 4 times negative 2.7 times 6.5 divided by 2 times negative 2.7. So this one, again, I would type this in at some point, but the answer is going to be 11.32 seconds. So I think when you type it in, if you did and it may not be the negative one that gives you the negative number, so I would still check both, but one of them is going to give you negative time, I'm pretty sure, which obviously cannot be the case. So also, just a quick note about your calculator when you're typing these in. There is, I don't know if you're going to be able to see it very good. So we have our typical minus sign over here on the side, but when we're typing in like the negative 2.7, we have to use this little negative sign that's in parentheses down here. Okay, if you use the minus sign, it's going to tell you there's an error. Okay, so make sure you use the negative sign that's at the bottom. But anyways, that's why I say check them now while you're doing problems. Like when we're done, try to type it in and make sure, at least with one of them, that you know how to type it in, so that way when you get to a quiz or test or something, you don't like get it wrong off of not being able to type it in correctly. All right. One more. Let's go to the next page, number 13, and then we'll be done. All right. Salaries in millions of dollars for rookies selected in the first round of the NFL 2014 draft can be approximated by the quadratic model y equals 0.0258x squared minus 1.30x plus 23.3, where x represents draft pick order. Players selected earlier in the round have higher salaries than those selected later in the round. So that kind of makes sense, right? So use the model to estimate the salary of the player selected first overall to the nearest tenth of $1,000,000. So first overall is going to be x equals 1. So we take this equation and we say y equals 0.0258 times 1 squared minus 1.30 times 1 plus 23.3. And so this is one of those sections where, you'll have your calculator. You're going to want to use your calculator to type stuff in. But this actually comes out nicely to be $22 million. So I'm writing million just because it's obviously not 22 and it says it's in millions of dollars. So I just want to make sure that I specify that's what that is. So then what is the estimated salary of the player selected 10th overall? So that's going to be x equals 10. So we do the same thing with just plugging in 10. So y equals 0.0258 times 10 squared minus 1.30 times 10 plus 23.3. And if you type all that in, you would get y equals $12.88 million. So, any questions about those? I know typically word problems are not the favorite of most classes, but there aren't too many more word problems we do throughout the year after we get through this chapter. So if you hate them, you just got to push through for a little bit longer. So, all right, anything that we did not do is technically your homework. I'll see where we're at the end of class. I probably will say they'll be due Wednesday technically. Tristan, you won't be in class on Wednesday because there's PSAT testing. So we won't do anything in class that day since you won't be in here for that. But Tuesday I am planning to probably start 1.6. And my goal is let's try to get through 1.6 and then we'll test next Friday on 1.1 to 1.6. But because it would be the last day of the quarter, if something happens and they're either like really, really bad and they hurt your grade, I would either on Monday when we come back in give you an opportunity to like do test corrections or something to get points back, or I'll just wait and put it on second quarter depending on what happens. So if it's gonna make people's grades drop drastically for some reason, then, which I don't think that will happen, but just I don't want anybody to freak out that it's the last day of the quarter and something might happen. So anyways, all right, y'all are free to work on that.